We end tonight with the clearest pictures yet of Neptune, the most distant planet in our solar system. Take a look. The striking infrared images were taken this summer by the James Webb Space Telescope.
James Webb turned its powerful eyes toward Neptune, and what it observed has left scientists completely puzzled. Strange patterns and unexpected signals are emerging from the distant blue planet, defying all current understanding. Clues have emerged pointing to the mysterious process behind Neptune's legendary diamond rain. Experts are hinting at secrets hidden deep within Neptune's atmosphere that challenge everything we thought we knew about the giant ice worlds of our solar system. The planet found by mathematics. Neptune is the most distant major planet in our solar system. It sits so far away from the Sun that no human eye can see it from Earth. Even Uranus, under perfect conditions, can sometimes be spotted as a tiny, pale dot, but Neptune remains hidden in the darkness. At an average distance of about 30 astronomical units from the Sun, it lives in a region where sunlight becomes weak and faint. Because of this enormous distance, early astronomers never expected to discover it in the usual way. They could not simply point a telescope at the sky and find it. Instead, Neptune revealed itself through mathematics. In the early 1800s, astronomers were studying Uranus, a planet that had only recently been added to the known list. As years passed, something began to bother them. Uranus was not moving the way the equations predicted. Its orbit drifted slightly, almost like an invisible hand was tugging at it. At first, researchers blamed the telescopes. Maybe people were measuring incorrectly. Maybe the data was unreliable. But a French mathematician named Urbain Le Verrier did not accept that explanation. He believed the problem was not with the observers. He believed another world was pulling on Uranus. Le Verrier studied the strange motions of Uranus with great care. He took every tiny shift and every small deviation and treated them as clues. Using these clues, he calculated where a hidden planet must be. The incredible part is that he did not guess. He worked out the exact spot in the sky where this unseen world should appear. He did not know its color. He did not know its size. He only knew it had to exist. After completing his calculations, he sent them to Johann Galle, an astronomer working in Berlin. Galle received the letter, pointed his telescope at the exact region Le Verrier described, and found Neptune that very night. It was a moment of triumph in the history of science. A planet had been discovered not by sight, but through pure reasoning. This achievement has never been repeated, yet the planet that appeared through equations was far more active and mysterious than anyone imagined. Beneath its calm blue glow waited forces and secrets that would one day shock every scientist who dared to look again. Voyager's single glimpse. For many decades after Neptune was discovered, it stayed almost untouched by human curiosity. Telescopes on Earth could only capture it as a small, blurry dot. No one could see its storms or its clouds or its rings. Neptune remained a distant stranger. That changed in the year 1989 when Voyager 2 arrived. This spacecraft had already visited Jupiter, Saturn, and Uranus on its long journey. Neptune was the final stop before it left the solar system forever. Voyager 2 did not slow down when it reached Neptune. It did not orbit the planet or spend months studying it. It flew past only once, but that single moment changed everything we thought we knew. The spacecraft passed only 5,000 kilometers above Neptune's cloud tops. That was closer to any other world. Because of this close approach, Voyager sent back the first clear images of Neptune. These were not vague shapes or colored smudges. They were detailed photographs showing a living world. Scientists expected Neptune to be calm. They thought a planet so far from the Sun would be cold, quiet, and almost frozen. But Voyager saw something very different. Neptune turned out to be a powerful and active world. Bright storms churned across its surface. Long streaks of clouds stretched over the top of the atmosphere. Strong bands of weather wrapped around the planet. The winds shocked everyone. They raced faster than the speed of sound on Earth. Some reached nearly 2,000 kilometers per hour. Nothing in the solar system matched these speeds. Voyager also revealed the Great Dark Spot. It was an enormous storm about the size of Earth. It spun in the opposite direction of Neptune's rotation. It looked solid and strong, as if it had existed for ages. Yet when the Hubble Space Telescope observed Neptune a few years later, the great dark spot had completely vanished. It had either broken apart or faded into the deep atmosphere. This told scientists that Neptune's storms do not behave like Jupiter's long-lasting Great Red Spot. Neptune's storms appear and disappear like breathing patterns. The spacecraft also discovered 6 new moons and confirmed the presence of rings, but these rings were nothing like Saturn's bright and perfect circles. Neptune's rings were faint and uneven. Some parts were bright, others nearly invisible. It was a puzzle why they stayed grouped together instead of spreading out. Voyager's single glimpse showed a world filled with motion and mystery. It left scientists with a feeling that Neptune was changing faster than anyone expected, as if the planet was alive beneath its icy outer skin. A world powered from within. After Voyager 2 left Neptune behind, scientists studied its data and realized they had witnessed a planet that behaved in ways no one fully understood. Neptune receives almost no sunlight compared to Earth. The light that reaches it is so weak that it barely warms the upper atmosphere. Because of this, researchers expected gentle breezes and slow-moving clouds. Instead, they found violent winds that moved faster than anything ever measured on any other planet. This raised a difficult question. If the Sun was not giving Neptune enough energy to power these storms, then what was? The answer seemed to come from deep inside the planet. Neptune releases much more heat than it receives from the Sun. In fact, it gives off more than twice the energy it takes in. This means its interior is still hot and active. Scientists think this internal heat rises upward and fuels the fast winds and swirling storms. It is almost as if Neptune has a fire inside that never goes out. This internal heat makes Neptune very different from Uranus. Uranus is almost the same size and has a similar composition, yet it hardly releases any heat from within. It appears strangely quiet and cold compared to Neptune. Why two similar planets behave so differently remains a major mystery. Some scientists believe Uranus may have suffered a massive impact long ago that changed its interior. Neptune, on the other hand, may have kept its natural heat and activity. Neptune's atmosphere is made of layers that behave differently. High in the sky, thin clouds of methane ice float above deeper layers. Below them, the atmosphere shifts and moves constantly. Some areas are bright, while others darken suddenly. Clouds appear, stretch, and fade within days. Even the seasons on Neptune are strange. The planet takes 165 years to orbit the Sun. This means each season lasts about 40 Earth years. A slight warming in the southern hemisphere can release methane from deeper layers. These methane particles rise and create new haze that changes the color and brightness of that part of the planet. In recent years, astronomers have noticed something even more surprising. The temperature in Neptune's stratosphere has dropped sharply. It has cooled much faster than any model predicted. Then, a sudden warming appeared near the South Pole. No one knows why. It may be part of a long seasonal pattern, or it may be caused by something happening inside the planet. Hubble keeps watch. Hubble watched Neptune for more than 30 years and slowly revealed that the planet was never still. It was constantly changing, shifting and behaving in ways no one expected. The first big surprise came in 1994, when Hubble spotted a new dark storm in the northern hemisphere. It looked similar to the great dark spot that Voyager had seen in the southern hemisphere, except this one had formed on the opposite side of the planet. Over time, Hubble found more storms. Some appeared in 2015, others in 2018 and 2020. These storms were not small swirls. They were giant spinning systems that stretched across huge parts of the planet. The behavior of one storm shocked scientists. Instead of drifting toward the equator and fading away like earlier storms, this one suddenly changed direction and moved back toward the pole. Nothing like this had been seen before. It suggested that Neptune's atmosphere was far more complex than the simple models scientists used to imagine. Air currents, temperature layers, and deep winds were likely interacting in ways that were hard to predict. Hubble also spotted bright clouds that floated above many storms. These clouds are made of methane ice and sometimes appear before a storm forms. Other times they wrap around the storm like glowing bands. These bright clouds change shape and position quickly. Sometimes they fade within a few days. Their rapid changes show how unstable Neptune's weather really is. In 2013, Hubble made another important discovery. It found a new, tiny moon just outside Neptune's rings. The moon is called Hippocamp and is only about 34 kilometers wide. Voyager 2 had missed it completely. The discovery of such a small moon raises the possibility that more hidden objects may still exist around Neptune. Hubble also helped astronomers track the inner moons of Neptune. Some of these moons move along tilted paths. They seem to weave around each other in a delicate pattern, almost as if they avoid collision through a natural rhythm created by gravity. The more Hubble watched Neptune, the clearer it became that a new set of eyes would soon be needed to uncover the next layer of secrets. When Webb looked at Neptune in 2022, Webb captured its first image of Neptune. Instead of a deep blue planet, it showed a pale sphere with glowing rings and thin white clouds sitting above the surface. Methane in Neptune's atmosphere absorbs most infrared light, so the planet looked almost transparent in certain areas. The rings, which had been nearly invisible since Voyager 2 saw them in 1989, now appeared sharp and bright. Webb even revealed faint dust bands that had remained hidden for more than 30 years. These pictures were impressive, but they were only the beginning. In 2025, Webb took a new set of observations that changed everything once again. This time, scientists saw Neptune glowing with bright patches of light. These glowing spots stretched across parts of the planet far from the poles. On Earth, auroras form near the north and south poles. On Neptune, something different was happening. Neptune's magnetic field is tilted at a strange angle and is not centered inside the planet. Because of this unusual shape, charged particles pour into unexpected parts of the atmosphere. Webb captured these events clearly. The bright areas contained a special molecule called H3+. This molecule forms when charged particles crash into the upper atmosphere. It is a sign of active auroras. For the first time since Voyager 2, scientists were able to measure Neptune's upper atmospheric temperature. They discovered that the temperature had changed dramatically since 1989 and that the upper layers were colder than expected. Webb also revealed several high-altitude clouds that floated above the lower atmosphere. These clouds reflected sunlight and appeared as bright white spots. Some were small and round, others stretched across long distances. Their shapes suggested that deep winds and rising heat were pushing materials upward in complex patterns. All of this made one thing clear: Neptune was not just active, it was restless, glowing and reacting to forces that scientists were only beginning to understand. Every new image opened the door to new mysteries. The more Webb observed Neptune, the more obvious it became that telescopes alone would never be enough. A planet this strange needed visitors, not just distant watchers. A planet of diamonds, fire, and unknown physics. Deep beneath Neptune's soft blue color lies a world that is nothing like the calm image seen from far away. The upper clouds are cold and gentle, but as you travel downward, the conditions quickly become extreme. The pressure grows until it becomes far greater than anything found on Earth. The temperature rises until it reaches levels that would melt rock. Scientists believe that at certain depths, the pressure becomes so strong that ordinary materials behave in strange ways. Methane molecules may break apart, releasing carbon that forms into hard crystals. These crystals may fall through the interior like shining stones. In other words, Neptune may have rain made of diamonds. This idea may sound like a story from a fantasy book, but laboratory experiments on Earth support it. Researchers have recreated some of the pressures inside ice giants by using strong lasers and powerful machines. Under these conditions, methane does break apart and tiny diamonds form. If this can happen in a laboratory for a brief moment, it can almost certainly happen inside Neptune, where the pressure remains strong at all times. Diamond rain may also explain why Neptune gives off so much internal heat. As diamonds sink deeper into the planet, they release energy. This warms the surrounding layers and helps drive the violent weather above. Neptune releases more than twice the energy it receives from the sun, so something deep inside must be generating that heat. Diamond rain is one possibility. Another is the presence of hot oceans made of water mixed with ammonia and methane. These oceans would not be like water on Earth. They would be thick, dark, and superheated, trapped under immense pressure. The inner structure of Neptune may contain several layers of superionic ice. This is a strange type of ice that behaves partly like a solid and partly like a liquid. The oxygen atoms form a solid structure, while hydrogen ions move freely inside, almost like electricity passing through wires. This unusual material could help shape Neptune's magnetic field, which is tilted and offset in a way that almost no other planet shows. The magnetic field does not seem to come from the center. Instead, it may be generated in the outer layers where these exotic forms of ice exist. Neptune and Uranus are often called twins, but they may be very different on the inside. Some scientists believe Uranus suffered a huge impact long ago that disrupted its interior and left it colder and quieter. Neptune may have avoided such a collision and kept its inner heat. The mysteries inside Neptune are not just about one planet. Because planets of similar size are common around distant stars, understanding Neptune could help us understand worlds across the galaxy. Neptune's hidden forces, glowing layers and possible diamond storms may reveal secrets about the universe that we have not even imagined yet. The case for a Neptune mission. As the years passed and telescopes kept showing Neptune changing again and again, a clear truth began to form among scientists. Neptune could not be understood properly from far away. The planet was too dynamic, too unpredictable, and too distant for Earth-based observations. Telescopes could capture a moment, a storm, a temperature shift, or a glowing patch of aurora, but they could not explain why these things were happening. The real answers were hidden deep inside the planet. To reach those answers, humanity needed something more than pictures. It needed a mission. People often ask why Neptune matters. The answer is simple. Neptune and its sister world, Uranus, belong to the class known as ice giants. These types of planets are extremely common in other solar systems. Most of the planets discovered around distant stars fall into the size range between Earth and Neptune. That means if we hope to understand other planetary systems, we must first understand the ice giants in our own. Neptune is not just one more planet, it is a key to thousands of others. Scientists have imagined what a dedicated Neptune mission would look like. The first requirement would be an orbiter. Unlike Voyager 2, which only flew past Neptune, an orbiter would stay around the planet for years. It would watch storms as they form, fade, and reappear. It would map temperature changes day by day. It would measure the magnetosphere and track how particles move through the atmosphere. Only a mission like this could reveal the true shape of Neptune's magnetic field, which remains one of the strangest in the solar system. Another idea involves sending a probe directly into Neptune's atmosphere. The probe would fall through the upper clouds and send back measurements of temperature, pressure, wind speed, and chemical composition until the crushing pressure destroyed it. Such a probe would provide the first real data from the deep atmosphere, data that telescopes cannot ever collect. There have been proposals. One of them is called Neptune Odyssey. It describes a powerful spacecraft that would orbit the planet and study its rings, moons, storms, and interior structure for a long period. Another idea has been discussed by researchers in China, who suggested sending a mission in the early 2030s, but none of these plans have been approved yet. Space missions take many years to design, build, and launch. If work does not begin soon, Neptune may remain unexplored for another generation. Neptune is a world filled with mysteries that keep growing as time passes. Every storm, every cloud change, and every strange glow seen by telescopes tells us that something deeper is waiting to be discovered. The planet seems to be calling for a closer look, one that only a true mission can provide. What do you think about Neptune's strange and powerful world? Share your thoughts in the comments and let us know which mystery fascinated you the most.